Greetings. We are doing a project about a balancing robot, and here is our setup. At the moment, our hardware is connected. You can see that the Arduino board is lighting and the system is connected as shown in Simulink. So from experiment, you can see that the motors are not moving at all. And the angle being read as a measured theta is 0 degrees. And then the pitch that's calculated from the IME filter is about that. So we shall tilt the balancing robot a bit to see the values that are read both for theta and for pitch, and see what happens for the actuators. So you can see that with a slight movement, even the slightest of movements, the motor is able to move. The motor is able to move, and hence the values read here has no change. And this shows that with a change in theta, the motors are able to run and counterbalance the angular displacement, and hence be able to balance the robot back to the 0 position. And as you can see, the motors keep running and can only stop when the position is back to 0. And as you can see, the values are fluctuating, and what you can pick from this is a desire or requirement to design a better system, a system that can more accurately read the values read and filter a little bit more for the results got. So you can see on leaving the system to settle again, the motors don't run, and the value read for measured theta is 0, which means we almost accurately have a model that can give us theta. And with slight improvement and finer tuning of the control and everything, could be able to get exactly what is designed and achieved as per the design mode of the system. With all this said and done, this could be the first video to demonstrate a bit of the work we've done for the controller design and implementation on the actual hardware of a running Simulink. Could dive in a little more on the components in each block, just briefly. This is our filter. This is the implementation to change the Euler angles to values that can be read. This block is just for pre-processing to be able to give us values. So we say if the angle received is less than 10, it should be able to counterbalance. It should be able to read. It should be able to read a value, and okay, in between 10 and negative 10 degrees, you should be able to counterbalance back to 0. It should be actually that value should be read as 0, and then when it's bigger than that, it's read as a big value. Hence, else we display that angle as the angle that has been got, and if it's less or between 10, we display 0, meaning it's almost balancing for the pitch. Then this is just a block for the system controller, where we have a PID controlling the errors received from the system for theta. And then here we change our force to torque, and then we use this lookup table to convert our torque to a PWM that is fed into our digital pins, and hence the input signal to the motor for them to run. Then mainly these are the Arduino blocks to represent the 2 pins 7 and 12, which are helping us transfer signals to pin 7 and 12, which are connected to the motors, and hence we are able to get an output as illustrated. Thank you.